Oh, button. Packet. सूर्यवती. अरे खेते ভাল লাগে না খেলতে. मेरा तो भाई क्या. Okay, good evening everyone. We will wait for a couple of more minutes for others to join, then we will start the session. Okay, so we will start the questions now. So this time we are having the week 5 live session on integrated waste management for a smart city. And like other days, today also we will be having 15 set of questions, and today we have some numerical questions which are basic and very easy questions, mostly on composting and related areas. So starting on with the first question, please let me know in case you have any doubts at any point. Please feel free to unmute yourselves and share that with us. And if you have any other thoughts or on the concepts also, then also you can uh, share the same. And please mute yourself so whoever is joining, in case if you don't have anything to say. Okay. So now, first question. Okay, so this is your question. To obtain a C by N ratio of 30 is to 1, how much sludge is to be mixed with 1 kg of leaves? And you have been provided the C and N content in 1 kg of leaves, that is 1 kg is having 0.3 kg of carbon and 0.005 kg of nitrogen. Similarly, 1 kg of sludge is having 0.1 kg of carbon and 0.02 kg of nitrogen. So you have to answer how much sludge is to be mixed with 1 kg of leaves to obtain a C is to N ratio of 30 is to 1. You can have about 5-10 minutes for this question and I will share the answers after some time. The options, sorry, not the answer. Okay, so for those who have joined just now, Vaishnavi, this is the first question that we are having. You have been given that the compost should have a C/N ratio of 30 is to 1, and how much sludge is to be mixed with 1 kg of leaves, where the carbon content in 1 kg of leaves is 0.3 kg, while nitrogen is 0.05 kg. Similarly, the values have been shared for sludge, and you have to determine the amount of sludge that is to be mixed with this leaves. Finish of record. डिनर जब नाश्ते है अभी कैसे समझना You can share your answers in the chat box. ওষুধ খেয়ে গিয়ে বা ল্যাপটপ নিয়ে খাবারটা দুটোই খেয়ে নে, নিয়ে টিয়ে রুমে গিয়ে রেস্ট কর। Okay, so as of now we have got one solution, that is 3 kg. Now we will solve the question and see how it turns out. So what is given to us? It is that C by N is equal to 30 by 1. This value is given. So numerator is carbon and denominator is your nitrogen. So first carbon. So 1 kg of leaves, it is already present. So how much carbon will be there in 1 kg of leaf? That is 0.3 kg. Okay. Plus, let's say you don't know how much sludge is required. So let's say the amount of sludge that is to be added, it is X amount of sludge is added. So if there is an X amount of sludge, then how much carbon will it have? It will have 0.1 kg of carbon is there in 1 kg of sludge. So X kg of sludge will have X into 0.1. This is the amount of carbon that will be present in this much sludge. Similarly, for nitrogen, in 1 kg of leaves, you have 0.005 kg of nitrogen, plus in X kg of sludge, you will have X into 0.02 kg of nitrogen. So now the things are very simple. Solve this equation and we will see what value we will get for X. Okay, so 0.3 kg. This is the correct answer. I hope this was very easy to understand. In case if you have any doubt in this, you can always ask. 0.3 kg of sludge is required. Now moving to the next question, which is again a very simple numerical based one. MC is moisture content. So individual moisture content of different components of the municipal solid waste will be shared with you, and you will have to calculate the overall moisture content. So I will just share the value and tables. Fine. So the components are paper, cardboard, so these are the five components and their mass percentages. They are These are the mass percentages and respective moisture contents. Okay. So individual moisture contents of the components have been shared with you. What you need to do is that you need to determine the overall moisture content of the municipal solid waste. For this question, you can have about again 5-10 minutes, and then I will share the solution with you. In case if you have any doubt in the previous question, please let me know. Please share your answers in the chat box, and I will also share the options. All the options are in percentages. Fine. Okay. So 3-4 minutes more, and then we will solve the question. Okay. So 23.2. Then 2-3 minutes more. Okay. So we will solve the question now. So these are the percentages. We will assume, like, we will see what they add up to. Most probably it will be 100, 55 plus 5, 60, 70, 80, 90, 100. So let's say there is 100 kg of your waste. So MSW mass, assuming 100 kgs. So how much total moisture we have? So total moisture. So see, 20 kgs of 10 kgs of paper, and it has a 3% moisture content. So very simple. 10 into 3% of 10. Everything will be divided by 100 only. Similarly for cardboard, again 10 into 4 divided by 100. Similarly for cloth, newspaper and others, same approach. 5 into 2 divided by 100. So how much is it? 30 plus 40 plus 40 plus 30, 70, 80, 120. Okay. So 23.2 kgs of moisture in 100 kg of waste. That means 23.2% is the overall moisture content of the entire MSW. I hope this was very easy to understand. So we will quickly move on to the next question. This is also a numerical based one, but a smaller one. So this is the question. A routing problem based question where you have been given that the waste collection vehicle, its pickup time per trip, it is 2.5 hours, while at site time per trip is 0.5 hours. Then you have to complete your round trip in 3.8 hours, that is the total time. So what will be the halt time allowed per trip? So please attempt this question. I will share the formula also with you in about 2-3 minutes, not 2-3, 4 minutes, and then I hope you can solve the question very easily. Option C, one of you have shared. Nice. So for others, to make it easier, because I will share the formula with you. Now it should be done very quickly. 3 out of 4 of these values they have been provided. You have to just find a single one. Okay, fine. So the total time is has been shared with you. You have to complete your round trip in 3.8 hours. That is the TFCS. So 3.8 hours. This is the total. Next, what is given? Pickup time per trip. It is 2.5 hours. So then again 2.5 hours is shared. Then at site time per trip is 0.5 hours. This is also given. What is remaining? Halt time. This halt time per trip. So now it's very simple, as one of you has already correctly solved the question with option C, 0.8 hours. So Asuti has correctly solved the question with the answer of H being 0.8 hours. Now moving on to question number 4, which is a theoretical type of question. Now the question is, which of the following parameters, I will share that with you, is not prominent factor to be considered while composting? Fine, I will repeat the question again. Not a prominent factor during composting. And your options are, you have to choose the one which is not a prominent factor. Particle size, inert composition, MC's moisture content, and seeding. So I think you can quickly answer this question. Which of these following is not a prominent factor during composting? Okay, option, which one? Option D, seeding. Okay, any other opinion? So during composting, I will share a slide with you, and then again I will rephrase the question. Okay, so the slide is not here, I guess. So see, during composting, the primary materials which are needed are moisture content. So first of all, biomass, then moisture content, and then supply of air. These three are the prominent materials. So if you look at this question, the particle size, we know that usually during most of the chemical or any chemical reaction, the smaller the particle size, more is the surface area exposed and better is the reaction rate. So that is why particle size is obviously a prominent factor during composting. Then comes the inert composition. So this seems a bit odd, this inert composition. Reason being, when I'm supposed to do composting, the feedstock or the material initial I have, that is obviously it should be biomass or degradable material. So what happens is that inert composition should not be there, and if at all it is present, it should be present in a limited amount, or if something is required in that aspect. Because sometimes it's some macronutrients someone externally wants to add it in certain special cases, then it is a different issue. But in usual composting, inert composition should not be there. So I think most of you must have guessed this correctly, that inert composition, it is a bit out of context. On the other hand, MC is moisture content. So moisture content is very much a vital thing that should be there for composting to occur. And then what is seeding? Seeding means it is a set of microbes that you first introduce to your feedstock. Now what happens, for example, you have a vegetable waste or you have a food waste and you want to prepare a compost out of it. So let's say what we usually do is that we usually in our households we dig a soil, put those material inside, and we can either let it stay there for some time, or at times we can mix it after certain durations. So in those cases, in case of seeding, what happens, the essential microbes that degrade the organic matter, they are coming from the soil and the other nearby ecosystem. But for example, if you are doing it in a some box kind of stuff and there you are throwing your organic waste and you want to compost, then those microbes which are important for composting, they won't be there. So in those cases, what we do, we seed it. Seed it means we take some sample of a compost or an active compost or any other suitable uh, mass in which there is already appreciable amount of microbes are present. We add those microbes into the composting mix and then properly agitate it and mix it. I guess I was clear. So seeding means there is a system wherein you have your feedstock, organic material, but there is an absence of microbes which are essential for preparing the compost. Either absence or there is a very limited amount. So you need to add some active microorganisms from outside which will help you prepare the compost, and whose proportion or amount will also increase with time. So that is why we put a certain mass of actively composting material from some place wherein composting is being already done, or some other suitable mass that has been undergoing aerobic processes that can also be added to prepare the compost. I hope that was clear. And seeding means basically that externally adding some microbes to it. And inert composition, this is the correct answer for this question, because inert composition is not a prominent factor during composting. And few other points to highlight. So what should be the optimum moisture content during composting? Optimum moisture content, it should be around 50 to 60%. This is what we will try to maintain, not more than that. And then what will happen if you have very high moisture content? For example, like our soil, which is having, let's say you have a 1 cubic feet of soil, and in there already we know there are numerous pores. So when we keep on adding water to the soil mass, so those pores keeps on getting filled and being replaced by water. So in case if there is too much water, so what happens then, as the pores, initially those pores contain oxygen or air, basically air from which the microbes can take the oxygen. So if you keep on filling more and more water, what will happen? The air will start getting displaced, and finally you will have a mass that has got very little or no air. So in those cases, the organisms, aerobic organisms which are necessary for composting, they can't function properly. And there is a very high probability that an anaerobic system may form there, due to which there can be emission of foul gases and various other problems. So that is why an optimum moisture content is necessary. So if in case like you have a mass, for example, you have your garden trimmings, leaves and all those stuff, so we know that they usually have very less moisture content, and you want to add some moisture to it externally. So one thing is that you can easily sprinkle water, but in case you don't want to waste your freshwater reserves, so what you can do is that people who come at a large commercial scale do composting, they can also get the sewage sludge, which has got huge 99% and more moisture content, 99.8 or something like that. They can add that sludge as it is as a moisture source. So that was it. Then blending and seeding, these things I have already told you. Okay, fine. And regarding the particle size, so what should be the particle size? The particle size should preferably be 25 to 75 mm. Fine. So this is done. Uh, then another thing is that why do we mix the compost again and again? First thing is that you will see in the upcoming questions that during composting the temperature starts to rise because it is an exothermic process. So if the temperature keeps on rising and we are not able to control it, then after a certain phase, the mesophilic bacteria which are also active, they will start to die off because the temperature then reaches the thermophilic phases or stages. So that is why we continuously mix it so that the heat can dissipate and again the air will come in, that mixing will occur. So that is one way. And how much it should be mixed? The answer is that the first turning usually which is done, or the first mixing, it should be done after 3 days and then after every fifth day. These all data, I hope this has already been shared with you in the slides that has been discussed by Professor Dubey during the online sessions. So now we will quickly move on to our next question, which is again a very important and basic theoretical question. So your question is, what should be the optimal carbon to nitrogen ratio in solid waste composting process? I have already shared the answer with you in the previous live sessions as well. Optimum C by N ratio for solid waste composting. Your options are, so these are your options. Which one do you think is the correct one? Option A, fine. Option A is also acceptable, but usually the traditional way in which we consider an optimum region, that is as told by Vaishnavi, it is option B, that is 20 to 25. But yes, if it is in case 25 to 30, composting can be done, but optimum one, it is 20 to 25. Then next question, and I will see if I have any slides on it. Yeah. So this is the slide. So you can see that the optimal range is 20 to 25%, and the composting time it increases when the C by N ratio it exceeds 40. So these are the some of the salient points, and then you can see like some of the characteristics C to N ratio of different wastes, organic waste like digested sludge. It has 15:1, which is very low. Yard waste, that is the trimmings like garden trimmings, leaves, twigs and all the stuff, it has got a very high ratio of 40 to 80:1. The newspaper, they have like absurdly high carbon content with C by N ratio being 175 to 800:1. Why are these ratios important and when can you make use of them? For example, you have a digested sludge wherein you want to convert it into a compost. So you can see that the digestive sludge is having very less this C content. So you need to externally add some carbon. In those cases, you can add yard waste to it. But ideally, we should be very careful when we are trying to prepare a compost out of digested sludge, and usually it is not suitable for that. But I am just taking an example. You have, instead of digested sludge, you have any other biomass which is having, let's say, the C by N content of 15:1, and you want to add some extra carbon from outside. In those cases, you can add some required proportion of yard waste. And how much yard waste should be added? It is calculated based on this first question how you have done. In this question, you saw that 1 kg of leaves were mixed with some amount of sludge, and you can see that amount of sludge that was required, it is very, very less as compared to leaves. 1 kg of leaves as compared to 0.3 kg of sludge. That is why. Usually, why we avoid adding too much sludge, the reason is that it has got various pathogenic organisms, and which can then, because in composting we have to go and mix it, there are various workers working there, so the probability of health risk, they also can rise exponentially, so that is why sludge amount should be low. Then again, here are a few examples, like newspaper. As you can see here, very high moisture, this carbon content and low nitrogen content. Yard waste is having high nitrogen content. So these are some of the supplementary materials that can be added, which can be manure or sludge. So then the next question. It is again a theoretical based one. I think you can answer this very easily. You have been asked like which kind of microbes ferment the intermediates like fatty acids or monosaccharides and amino acids into simple organic acids during biological conversion in a landfill environment. So which one do you think is the correct answer? If you look at the keywords, I think it will be very easy to find out. Option D. Any other guesses? I think most of you are going with option D, and then it is the correct answer. Option D. So moving on to the next question, that is question number 7. You have to identify the stage at which pH of a compost is in the range of 7 to 7.5. So pH of compost is 7 to 7.5. So you have to identify the stage in which the compost is. So thermophilic, hydrolyzing stage, neutral or mesophilic. For this, I can share a diagram with you. So from here, you can guess it. Yes, mesophilic is the correct answer. And few points, like here you can see that initially during composting, it starts with a mesophilic range where the pH is between 7 and 7.5. And as the days go by, the pH usually drops down to about 5. This is because the organic acids, they start getting formed due to various reactions that are taking place inside. Then the thermophilic stage, it is usually when the pH rises to around 8. You can see here in this diagram, around 8 means here, when the pH rises to somewhere here, you can see that this is the thermophilic range. Around 70 degrees, 65 to 70, this is somewhere the temperature is fluctuating. That is one part. Then what happens, like uh, in thermophilic stages, the pH rises, but we should always try to keep it below 8.5, because what happens, if the pH is increasing and goes beyond 8.5, then ammonia, it starts getting out of the system, out of the compost, and that ammonia, it has got essential nitrogen that acts as a nutrient. So we should prefer to always keep the pH below 8.5, and this can be done in here. You can see this can be done by continuously at regular intervals by mixing the compost. And then in case that is also not helping, then in certain instances you can additionally add lime, because we know that lime is basically calcium oxide and it increases the pH because it itself is a basic compound. And then mature compost, like which is already prepared, it has a pH of around 7, that is neutral. And then if one note, if aeration is insufficient, then the pH will drop down to 4.5 and the composting will struggle. Why is this? pH usually drops down to 5 or around 4.5 or goes below when more and more acids are being formed. And these acids, they kill off the useful bacteria, the mesophilic bacteria, aerobic ones that help in composting. That is why the quality of the compost, they also degrade. So these are few of the points. Then moving to the next question, which is question number 8. You have to determine the typical range of organic fraction that is present in a MSW. I will write it here. Organic fraction in MSW. What it can be. All of these are obviously in percentages. These are your options. Yes, option B is the correct answer. Usually it ranges between 30 to 80%. Here in this slide you can see 30 to 80% is the correct answer. And then on note, like you have a waste, in proximate analysis, what we do is that we determine its the characterization or the quality of the waste in terms of how much moisture content it has, how much fixed carbon it has, how much volatiles it has, and finally how much ash it has. So that is included in proximate analysis. So while doing proximate analysis, the one thing we start with is moisture content. And how to determine it? You take an initial weight of the organic material or MSW, put it in a hot air oven, heat it for 105 degrees centigrade for 1 hour, or if needed in certain situations, you can also increase like the this time period for 105 degrees Celsius. It can be 12 hours or 24 hours as per the protocol, because there are certain guidelines, CPHEO and other guidelines. I think not CPHEO, but there are certain guidelines of solid waste management, which already like tells you like how to determine the moisture content. In those cases, for 105 degrees centigrade, we can heat our material for about 12 hours or 24 hours. Then the mass loss, because 105 all the water vaporizes, so the material that stays behind, it is, if you subtract the original minus the material, the dry material, it will be the moisture lost, and you can use it to determine the moisture content. Now next thing is volatile combustible matter, that is the volatile content. So there are different methods to calculate it. Then finally, after that, fixed carbon content is there, and then ash content. In ash content, how we determine it is that we increase the temperature. It can be at 550 or sometimes it can be 950 as well. We keep it there. No, it is usually 550. We let the material stay there for about 2 hours, I guess, as per one of the codes. And then the material that is left behind, it is ash, because all the carbon has been removed and whatever is staying behind, it is basically ash. So in that way, you will have the amount of ash that is present in a material. Now, what is remaining? It is volatile matter content. So in one of the ways that we have calculated volatile matter content of coal-like materials is that we kept it in a muffle furnace at 900 degrees centigrade and allowed the material to stay there for around 7 minutes, and then quickly took it out. So what happened is that whatever the volatile material there was, it quickly got away from the mass that we have, and in that way, the mass difference between those initial and final weight, it will give me how much volatile metal has been lost. So finally, we will have the mass difference giving me the water content, then mass difference giving me the volatile matter. Again, the amount of ash that is left finally, it will give me the ash content. So finally, fixed carbon content is arrived at or calculated by subtracting all these three, water, volatile and ash content, from 100. Easy. I hope I was able to make you understand those methods. Then we will move on to the next question, which is again a very easy question. You have to determine the pH of a mature compost that we have just discussed in the previous slide. pH of mature compost. For this, I will not share the options because I hope you can quickly answer the question. What is the pH of a mature compost? Yes, I can see one of the answers, 7 to 7.5. Okay, fine. Yeah, it should be 7 or 7 to 7.5. Like, it should be as neutral as possible. So 7 or 7 to 7.5 are the correct answers. Now, finally, moving to question number 10. This is also a very easy question. You have to highlight or find the option which is not a product of aerobic composting. Your options are carbon dioxide, hydrogen sulfide, water, or all of the other. Very easy question. Option A, carbon, like you have to see which is not a product of aerobic composting. This not a product is the key for this question. Yes, option 2 is the correct answer because hydrogen sulfide, it is a product of anaerobic process. Therein hydrogen sulfide is formed. What happens in aerobic process? You can see from this reaction, you have your initial biological material which can be proteins, acids, organic acids, fats, carbohydrates and all. They react with oxygen because while composting, the microorganisms present there, they will also need some nutrients. Finally, you will be forming compost. New cells means new microorganisms. And in the form of gases, since it is an aerobic process, everything will be oxides, carbon dioxide, water, nitrates, sulfates. These are the materials which are formed, and it is also an exothermic process. You can see here heat is liberated during this process. That is why you need to keep on mixing the composting from time to time. Otherwise, the heat will increase and go to thermophilic ranges, and then if it further exceeds the important or useful microbes, they will start to die off, and the quality of the formed compost will also degrade. Then the next question is, so what is the process in which organic matter is converted in the absence of oxygen into methane and manure? Your options are, so which one do you think is the correct answer? Okay, option 3, one of you have said, others are also going with the same answer. So it is obviously correct. Anaerobic digestion is the true answer for this question. Fine. So the next one, Which of the following process does not fall under the category of biochemical treatment? Okay, which one? Again, a very basic and simple question. Yes, option D is the correct answer. Incineration, it is obviously not a biochemical treatment, it is rather a thermochemical treatment. Next is a true and false kind of question. Your statement is that during composting, the temperature rise is caused by endothermic reactions associated with microbial respiration. Is it a correct statement, true or false? True. Okay. Please think about it because while composting, the temperature is increasing. So if the temperature is increasing, that means the product in the products heat is generated. As you can see from this equation, heat is generated. And in whichever reactions heat is generated as a reaction product, they are known as exothermic reactions. And in case of heat is consumed or heat is added during the reactions, if you want to heat some reaction to prepare a product, then heat is a in the reactant side. It is an addition. In those cases, it is a endothermic reaction. So as correctly said by Muhammad Hashim, this is an exothermic reaction. So that is why the statement is false, because in case of endothermic, it should be exothermic, and rest it is fine with during microbial respiration. So it is a false statement. So now coming to our second last question. Like in this question, two statements will be there. One is an assertion and the other will be a reasoning. And then you have to choose the correct answer. Okay, so which one do you think is the correct answer? Please read the question carefully, then I will show you one graph and you can use the graph to arrive at your answer. Okay, so one of the answers we have got. I will also share a graph and then you can revisit your answer. Fine, so I will just share the graph with you. This is the graph. So now what do you think? Y-axis is temperature, x-axis is time, this is the pH variation, this is the temperature variations. In the question you have been saying that the temperature is usually maximum between 5 to 15 days of indoor composting, and the reasoning has been given that pH is usually stable between 7.5 and 8.5 during the initial phases. So now which one do you think is the correct answer? Please give a thought. Neither option 5 nor option 1 is correct. If you carefully look at the figure, you can understand. Yes, this is the correct answer, that A is true and R is false. Reason being, you can see here that when is the temperature maximum? It is somewhere maximum here. So in 5 days, you can see it starts rising, and up to around 15, you can say that it is fine. The temperature is maximum during this period. So assertion is fine. So now the reasoning, it states that pH is usually stable between 7.5 and 8.5 during initial phase. So you first see that 7.5 and 8.5 is here, and it is not this stability. It is not during the initial phase. The initial phase is this at here 0, and you see first the pH falls and then increases and becomes stable. So if the since the option is clearly stating that 7.5 to 8.5 during the initial phase, of course this is, you can understand from the figure that it is not like that in the initial, rather 7.5 to 8.5 stability is arrived at the end phase. So the reasoning is false. That is why I think option C, that is 3, it is the correct answer. A is true and R is false. Then moving on to the final question of the day. It is also an assertion and reasoning based question. So A is for assertion. Okay, so now which one do you think is the correct option? This has already been discussed in one of our slides today and a few questions as well. Okay, option A, that is the correct answer, because we have already seen that 25 to 75 mm is the optimum or the desired particle size during composting. And the reason is it should be smaller in size, because more the surface area, easier will be the reactions, and then better will be the compost. So both true, that is the fine, and both are true, and R is the correct explanation for assertion that has been said. So these were the 15 questions that we had for today, and I will quickly go through all these questions again in case those who have joined a session a bit late, they can also see them. Fine. So the first question was a numerical based one, where the desired C by N ratio of the compost has been shared with you, which is 30.1. What has been given is that sludge has been mixed with leaves, and you have a mix wherein 1 kg of leaves it is already present. You have to externally add some sludge, and that 1 kg of leaf it has carbon and nitrogen in the ratio of 1 kg of leaves is having 0.3 kg of carbon and 0.005 kg of nitrogen. Similarly, sludge is having 1 kg of sludge is having 0.1 kg of carbon and 0.02 kg of nitrogen. So you need to determine how much sludge should be added. So in this question you can see we assume the amount of sludge to be added as x. This equation we already found C by N ratio 30 is to 1 given. So 0.3 kgs carbon is there in 1 kg leaves, plus x is the amount of sludge, and in x amount of sludge there will be 0.1 times the carbon from this. Since 0.1 kg in carbon in this there in 1 kg of sludge, that is why x kg of sludge will have 0.1 into x kg carbon. Similarly, numerator is being written in the form of nitrogen requirement. Then solving this equation, we will get x is equal to 0.3 kg. The next question was also very simple and basic. You had to determine the moisture content of the overall MSW or the municipal solid waste. In here, you had been given the percentage, mass percentage of different waste materials, the different components of MSW, and for those individual components, you have been also provided the moisture content. So what we did is that we added this up, it was coming out to be 100. So we assume that there is 100 kg of material. So in that 10 kg of paper is there, and in which 3% is the moisture. So mass of moisture is 10 kg into 3 by 100. Similarly, we calculated the moisture, mass of moisture in all those 5 components and then added them up. So what will be the total moisture content? It will be total mass of moisture divided by total mass of MSW. So that is how we calculated the 23.2 kg as the moisture content. It can be either 23.2 kg, or if you want to denote it in terms of percentage, that also you can do. Okay, so in this particular question, it was a routing problem based question. You have been provided that the pickup time per trip for the waste collection vehicle was 2.5 hours, and at site time per trip was 0.5 hours, and the total time to complete a round trip was 3.8 hours. So you had to calculate the halt time. A very easy question. This is the formula which is required, that is the total halt time, sorry, not the total halt time, the total trip time, that is equal to, you have to add the pickup time per trip, that is P, S is the at site time per trip, which is 0.5, and H is the halt time, which is unknown, and you have to find. So then this is the equation, and you can calculate H is equal to 0.8 hours. Fine. So the next is was a theoretical question where the whether you have to choose a factor which is not prominent during composting. So we already have seen in the questions today that particle size is very important, moisture content is very important, seeding is also very important. What is not prominent or important is the inert composition, because composting by nature it should not have inert in it, rather everything should be preferably degradable ones. In case if you sometimes want to add something else, then it is a different matter, but ideally inert part should not be there. Whatever is there, if you are adding some nutrients and all, they are basically not inert and they take part in this biochemical reactions. So in the next question you have been asked what is the optimum C to N ratio for solid waste composting. The correct answer is 20 to 25 is to 1, that is 20 is to 1 to 25 is to 1 carbon to nitrogen ratio. After that, in next question, you have been asked like which of the microbes ferment the intermediate compounds into simple organic acids during biological conversion in a landfill. So in a landfill environment, we know there is a anaerobic stage which predominates others, and in those anaerobic processes during acidogenesis, the acidogens are active, which convert the intermediates into simple organic compounds. Next is pH of a compost is 7 to 7.5 during which stage? In here, the correct answer was option D, mesophilic. I will just cross check it again. Yes, mesophilic stage. Then the organic fraction of the MSW usually varies between 30 to 80%. After it, we have got the pH of a manure, a mature compost. It should be there, not manure. Compost. It should be 7 to 7.5, or it should be preferably neutral, that is 7. Then the next question was, which of these is not a product of aerobic compost? The correct answer is hydrogen sulfide, because hydrogen sulfide is formed during anaerobic processes. In aerobic processes, if you look at this reaction, what is formed? All the oxides, carbon dioxide, water, nitrites, sorry, this is nitrates and sulfates. These oxidized materials are formed. Next is the process in which organic matter is converted into methane and manure in the absence of oxygen. The correct answer is anaerobic digestion. Next question was, which of the following doesn't fall within the category of biochemical treatment? Of course, incineration was the correct answer because everything else is a biological process. Next is a true and false, wherein the statement was during during composting, the temperature rise is caused by endothermic reactions associated with microbial respiration. In here, instead of endothermic, there should be exothermic is the correct term. That is why this original statement is false. Because in endothermic reactions, you need to add or supply heat or energy to the system, while in exothermic, heat is generated as a product during the reaction or after the reaction. Next was assertion and reasoning based one. First statement, it states that the temperature is usually maximum between 5 to 15 days of winter composting, and the reasoning that is originally provided is pH is usually stable between 7.5 to 8.5 during the initial phase. So in here, option A was, that is A was true and R is false. Why? Because you can see that the temperature is maximum, you can see around 5 to 15 days, so you can agree like, okay, this is fine. But it also stated as a reasoning that 7.5 to 8.5 is a stable phase that is arrived at the start or initial phase. Rather, you can see here clearly from this particular graph that the 7.5 to 8.5 stable pH of the compost, it is arriving during the matured phase or at the later stage of the composting, not at the initial. So that is why the reasoning was false. And in the final question was the size of the solid waste particles. It should be in the range of 25 to 75 mm for composting. And the reasoning shared was that smaller the particle size, more is the surface area, hence better is the reaction surface that is available for microbes, and therefore composting will also be an easier affair in this case. So these were the 15 questions that we had for us today. In case if you have any doubt in these or you want to share something from your end, you're always free to unmute yourselves and discuss that with us. Okay, thank you. So we will be concluding our live session for week 5. This should not be 5, this should be 6. Should be 5. Yeah, so we will be concluding our week 6 live session today, and we'll be meeting again after 1 week next Monday for the week 7 live session. Thank you.